Welcome to IAOCS.com Food Tech Club. Today's topic is oleoresins and essential oils. Essential oils, also called volatile odoriferous oil, are aromatic oily liquids extracted from different parts of plants, for example, leaves, peels, barks, flowers, buds, seeds, and so on. They can be extracted from plant materials by several methods: steam distillation, expression, and so on. Among all methods, for example, steam distillation method has been widely used, especially for commercial scale production. Essential oils have been widely used as food flavors. Essential oils found in many different plants, especially the aromatic plants, vary in order and flavor, which are governed by the type and amount of constituents present in oils. Additionally, the amount of essential oil from different plants is different, and this determines the price of essential oil. Apart from aromatic compounds, indigenous pigments contribute to varying colors of essential oil. This can affect the application as ingredient in some particular foods. Essential oils have been known to possess antioxidant and antimicrobial activities, thereby serving as natural additives in foods and food products. It can be used as active compounds in packaging materials in which the properties of these materials, particularly water vapor barrier property associated with hydrophobicity in nature of essential oils, can be improved. Also, any part of plant may be the source of the oil, which could be extracted and fully exploited for food applications or others. Modern technologies have been continuously developed to conquer the limitation of conventional methods and to enhance the extraction efficacy. Due to the increasing attention in natural additives, essential oils from several plants have been used more widely, especially in conjugation with other preservation under the concept of hurdle technology. Thus, essential oils can serve as alternative additives or processing aid as green technology. Several plant contains essential oils. However, parts of plants which serve as the major source of essential oil can be different. Those include roots, peels, leaves, seeds, fruits, barks, and so on. Plant essential oils are usually the complex mixture of natural compounds, both polar and non-polar compounds. In general, the constituents in essential oils are terpenes, which include monoterpenes and sesquiterpenes, aromatic compounds like aldehyde, alcohol, phenol, methoxy derivatives, and so on, and terpenoids, which include isoprenoids. Compounds and aroma of essential oils can be divided into two major groups: terpene hydrocarbons and oxygenated compounds. Terpene hydrocarbons are the molecules. The hydrocarbons are the molecules constituting of hydrogen and carbon atoms arranged in chains. These hydrocarbons may be acyclic, alicyclic, that is monocyclic, bicyclic, or tricyclic, or aromatic. Terpenes are the most common class of chemical compounds found in essential oils. Terpenes are made from isoprene units, several 5-carbon base units, which are the combination of two isoprene units called a terpene unit. Essential oil consists of mainly monoterpene C10 and sesquiterpene C15. The diterpenes C20, triterpenes C30, and tetraterpenes C40 exist in essential oils at low concentration. Terpenoids, a terpene containing oxygen, is also found in essential oils. Essential oils mostly contain monoterpenes and sesquiterpenes, which are C10H16 and C15H24 respectively. Although sesquiterpenes are larger in molecules, structure and functional properties of sesquiterpenes are similar to the monoterpenes. For diterpenes, triterpenes and tetraterpenes, they have the larger molecule than monoterpenes and sesquiterpenes, but they are present at very low concentration in essential oils. Oxygenated compounds. These compounds are the combination of carbon, hydrogen, and oxygen, and there are variety of compounds found in essential oils. Oxygenated compounds can be derived from the terpenes, in which they are termed terpenoids. Some oxygenated compounds prevalent in essential oil are like phenols, monoterpene alcohol, aldehydes, ketones, esters, oxides, lactones, and ethers. Different constituents in essential oils exhibit varying smell or flavor. Also, the perception of individual volatile compounds depends on their threshold. Essential oils can be extracted from several plants with different parts by various extraction methods. The manufacturing of essential oils and the method used for essential oil extraction are normally dependent on botanical material used. State and form of material is another factor used for consideration. Extraction method is one of prime factors that determine the quality of essential oil. Inappropriate extraction procedure can lead to the damage or alter action of chemical signature of essential oil. This results in the loss in bioactivity and natural characteristics. For severe case, discoloration of odor or flavor as well as physical change such as increased viscosity can occur. Those changes in extracted essential oil must be avoided. Extraction of oils can be carried out by various means. Steam distillation, the distillation method which includes steam distillation, hydrodistillation, hydrodiffusion. Steam distillation is the most widely used method for plant essential oil extraction. The proportion of essential oils extracted by steam distillation is 93% and the remaining 7% can be further extracted by other methods. Basically, the plant sample is placed in boiling water or heated by steam. The heat applied is the main cause of burst and breakdown of cell structure of plant materials. As a consequence, the aromatic compounds or essential oils from plant material are released. The temperature of heating must be enough to break down the plant material and release aromatic compound or essential oil. A new process design and operation for steam distillation of essential oils to increase oil yield and reduce the loss of polar compounds in wastewater was developed by Masango. The system consists of packed bed of the plant materials which sits above the steam source. Only steam passes through it and the boiling water is not mixed with plant material. Thus, the process requires the minimum amount of steam in the process and the amount of water in the distillate is reduced. Also, water-soluble compounds are dissolved into the aqueous fraction of the condensate at a lower extent. The 2,2-diphenyl 1-picryl hydroxyl, that is DPPH, radical scavenging activities of essential oils from steam distillation process were markedly higher than those of oils extracted using hydrodistillation. Hydrodistillation has become the standard method of essential oil extraction from plant materials such as wood or flour, which is often used to isolate non-water soluble natural products with high boiling point. The process involves the complete immersion of plant materials in water followed by boiling. This method projects the oil extracted to a certain degree since the surrounding water acts as barrier to prevent it from overheating. The steam and essential oil vapor are condensed to an aqueous fraction. The advantage of this technique is that the required material can be distilled at a temperature below 100 degrees Celsius. Hydrodiffusion extraction is a type of steam distillation which is often different in the inlet way of steam into the container of still. This method is used when the plant material has been dried or is not damaged at boiling temperature. For hydrodiffusion, steam is applied from the top of plant material whereas steam is entered from the bottom for the steam distillation method. The process can also be operated under low pressure or vacuum and reduces the steam temperature to below 100 degrees Celsius. Hydrodiffusion method is superior to steam distillation because of a shorter processing time and a higher oil yield with less steam used. Solvent extraction. Conventional solvent extraction has been implemented for fragile or delicate flour materials which are not tolerant to the heat or steam distillation. Different solvents including acetone, hexane, petroleum ether, methanol or ethanol can be used for extraction. For general practice, the solvent is mixed with the plant material and then heated to extract the essential oil followed by filtration. Subsequently, the filter is concentrated by solvent evaporation. The concentrate is resin, that's resinoid or concrete, which is a combination of wax, fragrance and essential oil. From the concrete, it is then mixed with pure alcohol to extract the oil and distilled at low temperature. The alcohol absorbs the fragrance and when the alcohol is evaporated, the aromatic absolute oil is remained. However, this method is a relatively time-consuming process, thus making the oils more expensive than other methods. Essential oils with antioxidant activity from Trichotis verticilla extracted using solvent extraction method. It showed that oil was dominated by phenolic compounds 48.0% with carvacrol 44.6% and thymol 3.4% as the main compounds. Supercritical carbon dioxide. Conventional methods including solvent extraction and steam distillation have some shortcomings such as long preparation time and large amount of organic solvents. Moreover, the losses of some volatile compounds, low extraction efficiency, degradation of unsaturated compounds, and toxic solvent residue in the extract may be encountered. Therefore, supercritical fluids have been considered as an alternative medium for essential oil extraction. Carbon dioxide is the most commonly used supercritical fluid because of its modest critical conditions. Under high pressure condition, carbon dioxide turns into liquid which can be used as a very inert and safe medium to extract the aromatic molecules from raw materials. No solvent residue remains in the final finished product since the liquid carbon dioxide simply reverts to a gas and evaporates under normal atmospheric pressure and temperature. Despite high solubilities of essential oil components in supercritical carbon dioxide, the extraction rates were relatively slow with pure carbon dioxide. However, the combination method by a 15-minute static extraction with methylene chloride as modifier followed by a 15-minute dynamic extraction with pure carbon dioxide yielded high recoveries. The extraction efficacy was equivalent to hydrodistillation, which was performed for 4 hours. The volatile compounds such as monoterpenes can be collected from the supercritical fluid extraction, effluent by greater than 90%. Supercritical fluid extraction was able to recover some organic compounds that were not extracted by hydrodistillation. Supercritical fluid extraction is economically viable than steam distillation. This is mainly caused by the lower yield and the higher energy consumption of the latter. Subcritical water. The subcritical water or pasteurized hot water has been introduced as an extractant under dynamic conditions, pressure high enough to maintain water under liquid state and temperature in the range of 100 to 374 degrees Celsius. The efficacy in terms of essential oil per 1 gram of plant of continuous subcritical water extraction was 5.1 times higher than hydrodistillation method. This method is quicker, 15 minutes compared with 3 hours, provide a more valuable essential oil with higher amount of oxygenated compounds and no significant presence of terpenes, and allow substantial savings of cost in terms of both energy and plant material. Subcritical fluid extraction of lactones from a kava root compared to a oxalate extraction with water. The extraction of ground sample with subcritical water at 100 degrees Celsius took 2 hours, but the shorter time, 20 minutes, was required when extracted was carried out at 175 degrees Celsius. Boiling for 2 hours and extraction with oxalate apparatus for 6 hours showed that the lower yields by 40% to 60% compared with that obtained using subcritical water. Solvent-free microwave. The disadvantage of conventional methods such as solvent or hydrodiffusion extraction are the loss of some volatile compounds, low extraction efficiency, long extraction time, degradation of unsaturated or ester compounds through thermal or hydrolytic effects, and toxic solvent residues in the extract. These disadvantages are led to the consideration of the use of solvent-free microwave extraction. It is a rapid extraction of essential oil from aromatic herbs, spices and dry seeds. Solvent-free microwave extraction has several advantages involved higher yield and selectivity, shorter time and environment friendly. Solvent-free microwave extraction has several advantages involving higher yield and selectivity, shorter time and environment friendly. This is a combination of microwave heating and dry distillation performed at atmospheric pressure without any solvent or water. Isolation and concentration of volatile compounds are performed by a single stage. Using oregano as a raw materials, the solvent-free microwave extraction offers significantly higher essential oil yields compared to hydrodistillation. When microwave power at 62 volt was used in solvent-free microwave extraction, process time was reduced by 80% compared with conventional process. The microwave method offers the important advantage over traditional alternatives such as shorter extraction time, 30 minutes compared with 3 hours for hydrodistillation and 1 hour for cold processing. Better yields, 0.24% compared with 0.21% for hydrodistillation and 0.05% for cold processing. Environmental impact. Energy cost is appreciably higher for performing hydrodistillation and for using mechanical motors than that required for rapid microwave extraction. Cleaner features as no residue generation and no water or solvent used, and high antimicrobial activities. Essential oils can be classified severely based on their different methods of extraction, chemical composition, notes, aroma, etc. Classification based on chemical composition. There are numerous chemicals that can be found in essential oils that are present in different plants. Citrus and pine contain hydrocarbon, which are made up of only carbon and hydrogen atoms. Alcohol contains a hydroxyl group attached to the terpene structure that can be found in coriander, tea tree and peppermint. Aldehyde contains terpenoid with a carbonyl group and a hydrogen bonded to a carbon found in citronella, lemon balm, and lemon myrtle. Cyclic aldehydes contains aldehyde groups attached to a benzene ring and are common in cinnamon, bitter almond, and cumin. Ketone contains a carbonyl group bonded to a two carbon atoms. This can be located in plants such as pennyroyal, thuja, sage, and eucalyptus radiata. Phenol contains hydroxyl groups attached to a benzene ring in thyme and oregano. Phenolic ether contains an oxygen between carbon and benzene ring. Oxide as an oxygen bridging two or more carbons contained in eucalyptus, wormseed, and cagewood. Ester is a condensation product of acid and alcohol like lavender, wintergreen, and clary sage. Phenyl propanes are found in plants such as aniseed, clove, tarragon, and myrtle leaf acts as carminative and anesthetic. Sesquiterpenes like German chamomile and yarrow acts as anti-inflammatory and antiviral. Sesquiterpenes lactones such as elecampane and arnica act as mucolytic and immune stimulating. Classification based on extraction methods. Essential oils can be grouped by their extraction methods. Nowadays, different methods are used in extraction, but the most common and prevalent methods are steam distillation, cold processing, and solvent extraction. Based on these methods, essential oil can be classified into four different types: steam distilled, expressed, solvent extracted, and absolute or concretes. Classification based on aroma. Essential oils can also be classified based on aroma, smell of the oil. This classification of oil can be categorized into citrus, herbaceous, medicinal, or camphorous, floral, resinous oil, and woody, earthy, minty, and spicy oils. Citrus oils, essential oils that have a distinct citrus flavor fall into this category. Bergamot, grapefruit, lemon, lime, orange, and tangerine are some of the plants that produce citrus oil. Herbaceous oil, oils that are extracted from plants which are otherwise most useful herbs. These oils can be extracted from plants such as basil, chamomile, melissa, clary sage, hyssop, marjoram, peppermint, and rosemary are some of this kind. Camphoraceous oil, these are essential oils with a particular healing property. Some of these essential oils are obtained from cagewood, tea tree, bourgeon-like earthy and mugwort-like and rosemary-like with a fruity, dried, plum-like background. Floral oils, oil made from floral parts or which carry the floral essence of the plants fall under this group. Geranium, jasmine, lavender, rose, neroli, etc. are some of the plants that produce this oil. Woody oils, essential oils that are woody in aromas are extracted from the barks and other woody parts of plants. Cedar wood, cinnamon, cypress, juniper berry, pine, and sandalwood, etc. produce such oils. Earthy oils, essential oils that have a distinct earthy aroma or are extracted from plants' roots and other earthy parts. Angelica, patchouli, vetiver, and valerian produce some of these oils. Spicy oils, oils extracted from spices or spicy plants such as thyme, cloves, aniseed, black pepper, cardamom, cinnamon, coriander, cumin, ginger, and nutmeg. The use of essential oils as antimicrobial additives in food has been categorized as GRAS, generally recognized as safe by the US Food and Drug Administration, and are rich source of biologically active compounds with non-antimicrobial and antioxidant properties, which attracts interest as additive in the food industry. However, their application as food additive is the recent growing interest in the view of their strong antimicrobial and antioxidant properties. The basic approach to ensure food safety is to minimize the initial microbiological load or to inhibit the growth of the remaining microorganisms during post-process applications like production and storage by the use of an active packaging. Cinnamon essential oils have been characterized as the most relevant essential oils used in both food and cosmetic industries, and particular as an antimicrobial agent due to its many applications as flavoring agent and as an aroma. According to Simeonato, the encapsulation of cinnamon oil in cyclodextrin nanosponges serve as a potential use for antimicrobial food packaging. Furthermore, garlic essential oil nanophytosomes as a natural food preservative with its application in yogurt as food model showed its potential as possible natural food preservative by effectively displaying suitable physicochemical properties, particularly in acidic food products. Studies have shown that essential oils exhibit a strong antimicrobial activity towards foodborne pathogens, which can be exploited by the food industry to use it as a preservative or to incorporate it in food packaging as antimicrobial agent. Active edible coatings containing natural antioxidants could improve meat product stability and therefore have potential use in food industry. Essential oil as edible coating material in food. Edible films and coatings are generally based on biological materials such as proteins, lipids, and polysaccharides, alone or more often in combination. The utilization and selection of essential oils ought to contemplate the buyer's sensory acceptability to the ultimate product. In fact, due to their steady flavor, their direct use is usually restricted. Therefore, essential oils can be added into edible coatings, which have been suggested as an alternative food packaging to improve food safety and quality. A critical need of the food industry is to prevent the development of spoilage microorganisms related with fresh food and their products. Bioactive bundling system has been considered as a promising innovation that has a critical impact on shelf life expansion and security of the product. Desirable effect of microbial and enzyme inactivation results in the loss of organoleptic and nutrient level of the produce. Therefore, it is important to develop effective storage methods and alternative technology to preserve and improve the storage quality and shelf life of foods. Essential oils and their components have great potential as natural antimicrobial agents to control the growth of pathogenic and spoilage bacteria in foods. The antimicrobial properties of many plant essential oils are that is gelatin based edible coating incorporated with mentha pelagium essential oil. The mode of application of the product is bioactive packaging for strawberries and it inhibits the total flora and molds and yeast. But the microbial inhibition magnitude was dependent on the concentration of essential oil. In the case of chitosan lemon essential oil, it is used during storage, keeping quality of strawberry. It slowed down the respiration rate and enhanced antifungal activity both in vitro test and during cold storage. But the use of microfluidization to prepare chitosan lemon essential oil did not improve the water barrier properties of the films. Lemon oil should be incorporated at a lesser concentration in the film to minimize its impacts on the olfactory perception. Essential oils and other application in food and other products for controlling the development of foodborne pathogens and microorganisms have been performed by including an essential oil directly into the product as an ingredient or consolidating it into an edible coating material and films to protect the surface of the product. Pharmacological application of essential oil. Essential oil has been described to contain diverse pharmacological properties. In the recent, individuals and companies have developed means of impacting their effects in pharmacological product. In the recent, individuals and companies have developed means of impacting their effects in pharmacological products. In China, 6 laminaceous species commonly used are Perilla frutescens, Brit, Progestimon cabeline, Benth, Mentha haplocalix, Brick, Rosmarinus officinalis, Lin, Lavandula angustifolia Mill, and Scutellaria bicalensis Georgi. These herbs and their extracts have been utilized as anti-tumor, antioxidant, antimicrobial, and anti-inflammatory agents. Anti-inflammatory activities of the 6 essential oils is demonstrated by 12O tetradecanol furbol 13 acetate, that is TPA induced ear inflammation model, and the result indicated that these 6 essential oils inhibited inflammation to some extent in dose dependent manner, markedly relieved ear edema. Some essential oils and their components might be potent natural antioxidants. Bacterial pathogens nowadays become resistant to multi-drug antibiotics, and this has led to an increase in severity of diseases. They have ability to form biofilm associated drug tolerance and also weak immunity in host cells, lead to increase in number of life-threatening bacterial infection in human body. In view of this, essential oils and their chemical composition have been obtained from plants as a potential to control multi-drug resistant pathogenic microorganisms to combat various infectious diseases. In addition, essential oil derived from medicinal plants such as, for example, peppermint, mentha piperita, thyme, Thymus vulgaris, fennel, Funiculum vulgare are reported to be effective against gram-negative and gram-positive bacteria, viruses, fungi, and yeast. Essential oils are reported to aid in defense mechanism in higher plants. Essential oils also contain camphene, terpineol, alpha-pinene, alpha-thujon camphor, beta-thujon, which inhibits Enterococcus faecalis, Klebsiella pneumonia, etc. These essential oils, among others, have been used for oral and dental treatments. Their antioxidant properties of essential oils and their insect repellent properties has been confirmed. Oleoresin is a viscous liquid or semi-solid material derived by extraction from finely ground powder which contains the aroma and flavor of its source. Oleoresins are flavored compounds obtained by the solvent extraction of the ground spices. They have aroma and pauses and attributes which contribute to the taste-like pungency. All spices contain essential oils in various proportions which can be extracted by steam distillation. Oleoresins are preferred because of their microbiological advantages and uniformly in flavor and pungency, easy to store and transport. They have several applications like preparation of beverages, soup powders, curry powders, confectionaries, noodles, canned meat, sauces, etc. Types: Ajuvan seed oleoresin, black pepper oleoresin, capsicum, chili oleoresin, cardamom oleoresin, cassia bark oleoresin, celery seed oleoresin, cinnamon bark oleoresin, clove bud oleoresin, coriander seed oleoresin, cumin seed oleoresin, curcumin powder, date extract, fennel seed oleoresin, galangal oleoresin, ginger oleoresin, juniper berry oleoresin, mace oleoresin, nutmeg oleoresin, olibanum resinol, parsley seed oleoresin, turmeric oleoresin, white pepper oleoresin, zingiber oleoresin, paprika oleoresin. Manufacturing process: various raw spices are cleaned and then ground to require meshing size. The extraction is undertaken with the help of proper solvent. The solvents that can be used are hexane, acetone, ethylene dichloride or alcohol. Extraction is done by percolation of the solvents at room temperature through a bed of ground spices packed in an stainless steel percolator. The dark viscous extract contains not less than 10% of total soluble solids are drawn off and distilled under reduced pressure to remove the excess of solvent. The essential oil is obtained by steam distillation. Paprika oleoresin, also known as paprika extract, is an oil-soluble extract from the fruits of Capsicum annuum, lin or capsicum fruit scent, that's Indian red chilies, and is primarily used as a coloring and or flavoring in food products. It is composed of capsaicin, the main flavoring compound, giving pungency in higher concentration, and capsanthin and capsorubin, the main coloring compounds, among other carotenoids. Extraction is performed by perlocation with a variety of solvents, primarily hexane, which are removed prior to use. Foods colored with paprika oleoresin include cheese, orange juice, spice mixtures, sauces, sweets, and emulsified processed meats. In poultry feed, it is used to deepen the color of egg yolks. In the United States, paprika oleoresin is listed as a color additive exempt from certification and generally classified as natural color. In Europe, paprika oleoresin and the compounds capsanthin and capsorubin is designed by E160C. Turmeric oleoresin. It is extracted from Curcuma longa, L, a member of ginger family, obtained by solvent extraction of the ground spice containing coloring matter, volatile oil, fatty oil, and bitter principles. It is orange-red in color and consists of an upper oily layer and a lower crystalline layer. Coloring components are curcumin and curcuminoids. It is fat and alcohol soluble, cold water insoluble. Commercially dissolved curcumin in polysorbate 80 or 60 to make it water dispersible. It has good heat stability and poor light stability. The color hue change with pH: greenish in acidic pH, orange yellow in neutral pH. More stable in acidic pH than in neutral or alkaline pH. Used in pickle, bakery, confectionery, pudding, gelatin, gummy bears, yogurt, popcorn, and finger foods. Black pepper oleoresin. Oleoresin black peppers is a natural extract of dried tender berries of Pipernigrum lin of family Piperaceae. It is obtained by the solvent extraction of black pepper, and the solvent traces are removed by distilling it in vacuum at controlled temperature. Physical appearance: it is yellowish brown viscous liquid with pungent, slightly biting aroma of black pepper. Spice equivalent: about 5 to 10 kgs of oleoresin replaces 100 kgs of dried black pepper. Packing: 10, 20 and 40 kg high density polyethylene carboys, 5, 10, 20 to 40 stainless steel containers. Shelf life and storage: 18 months. Product should be stored in a full tight containers at controlled atmosphere, protected from direct heat and light. Rosemary oleoresin. Rosemary oleoresin extract, also known as ROE, is not a preservative. It is an antioxidant. This slows the rancidity of oils. If using to extend the shelf life of fixed oils such as hemp, avocado, etc., it must be added to the oils when they are fresh before oxidation has started. It is also most effective if thoroughly dispersed in the oil. Rosemary oleoresin extract is a thick liquid which can be difficult to blend. It is suggested to remove a small portion of the base oil, mix thoroughly, and then reintroduce this into the bulk fixed oil. Rosemary oleoresin will also add shelf life to sugars, salts, scrubs, balms and moisturizers, creams and lotions, and it is added during the cool down phase and when the preservatives is added to the formula. Usage: 2 to 10 drops per 100 gram of product. Usage rate: 0.1% to 0.5%. Ginger oleoresin on steam distillation: dried, cracked and comminuted ginger yields 1.0 to 3.0% of pale yellow viscid oil. The oil possesses the aromatic odor but not the pungent flavor of the spice. Of course, the odor of the oil is quite lasting. Ginger oleoresin is obtained by extraction of powdered dried ginger with suitable solvents like alcohol, acetone, etc. Unlike volatile oil, it contains both the volatile oil and the non-volatile pungent principles for which ginger is so highly esteemed. Concentration of the acetone extract under vacuum and on complete removal of even traces of the solvent used yields the so-called oleoresin of ginger. Ginger oleoresin is manufactured on a commercial scale in India and abroad and in great demand by the various food industries. The aroma of ginger is pleasant and spicy and the flavor penetrating, slightly biting due to antiseptic or pungent compounds present in it, which makes it indispensable in the manufacture of number of food products like gingerbread, confectionery, ginger ale, curry powders, soft drinks, vegetable, meat and fish curries, ginger cocktail, sauces, etc. Ginger preserves and ginger candy prepared from green or fresh ginger is quite favorite of many and fine great demand. A number of alcoholic beverages are prepared from ginger in foreign countries such as ginger brandy, ginger wine, ginger beer, etc. Cinnamon oleoresin is prepared by extracting cinnamon bark with organic solvents. Oleoresin yield varies from 10 to 12%. The oleoresin is dispersed on sugar, salt and used for flavoring processed foods. Goodbye for today. Continue your studies with iiocs.com Food Tech Club. For any queries, contact the number on the screen.